So here we continue on with the previous day where we're just looking at quadratic functions. Here we've been given a vertex and a point. So again, if we're given a vertex and a point, really we want to be using the vertex form. We should always kind of try to at least visualize what this looks like. So it's 2 over 6 down, and so 2 over 6 down, maybe somewhere around here, and it's 3 over 9 down, so something like that. So looks like our parabola is probably going to be some upside down parabola, and it looks like it's been just by the numbers, it looks like it's maybe been vertically expanded and flipped upside down. So given the vertex, that's key information. We want to put it into the vertex form or the graphing form, and all we really need to do to solve this form is to find the a value. So that's going to be minus 6. Okay, and the a value we already kind of know is going to be negative, but we need to know the amount has been expanded or compressed. So we're going to plug in the other coordinate, negative 9 for y, and we're going to put in 3 for x. Okay, and it's only 1 unit to the right of the vertex, so we're going to have very little change in that coordinate. Okay, so solving for the a value, we're going to add 6 to both sides. We end up with negative 3. 3 minus 2 squared is 1, so we end up with 1a. So a equals negative 3. And that's kind of what we expected. It's upside down. It's been vertically expanded by 3. So then the equation works out to be negative 3 as my a value. And the vertex is going to be at 2, and make sure we square that as well. Okay, so it's going to be x minus 2 squared. And then minus 6 is the y-coordinate of that vertex. Okay, so here's another graph. Here we've been given the standard form or the general form, and we've been given a is negative 1, b is negative 5, and we want to find c. Okay, and really this is a really simple but important piece of functions and graphs. If you got a point on the graph, an xy coordinate, it fits into the xy equation, and that's just a basic mathematical truth. So if I plug in the x and y that I've been given here, so here's my x, there's my y. If I plug it into the xy into the equation, the only variable that I don't know is c. So then I can solve for c if there's only one thing that I don't know. So negative 22, x is going to be 3, plus negative 5 times x is 3 plus c. That's c is the only thing unknown in this equation. So then I just work this out. So negative 22 is equal to negative 9. This is going to be negative 15 plus c. So add 24 to both sides. Okay, so that's going to be a 0 pair here. Okay, so that all cancels out. And we end up with c is equal to positive 2. So the equation then, the function here is negative x squared minus 5x plus 2. Okay, and that ends up being the y-intercept as well. Okay, so what about this one? We've been given a function. We have zeros at 2 and negative 4. So again, we want to at least visualize this. And so I'm going to have 0 is at negative 4 and negative 2, or positive 2. And we have a y-intercept at 4. So somewhere maybe up here. So I can see right away that this is going to be, it's got to be an upside down parabola. It's going to look something like that. Let me just draw a little bit better picture here. So it's got to be an upside down parabola. And it's going to come up like that. It's going to come down through there like that. Okay? So there y-intercept's at positive 4. So already I can kind of see that I should expect my a value to be negative. Okay, so how do I find this? Well, I have the factors, so I could use a factored form. So the factored form would look like this. And it's important to know that it doesn't matter which form you use. They're all solvable, but one's just going to be easier than another. Given the information of the zeros, we should really be thinking factored form. Okay, the y-intercept does give us general form information, but we want to try to avoid the general form if we can. So I'm going to use my factored form. So I get y equals, and don't forget the a, there's always an a. It's going to be x minus 2 for one 0, and x plus 4 for the other 0. Okay, so my negative 4, 0 gives me a plus 4 factor. And I need to solve for a, so I can use the y-intercept coordinate. The y-intercept coordinate is y is 4 when x is 0. So I end up with negative 2 times positive 4. Okay, so that ends up being negative 8a equals positive 4. Okay, divide by negative 8. I end up with negative 1/2. So we end up with an upside down parabola that's been vertically compressed a little bit. And my equation ends up being y equals negative 1/2 x minus 2 x plus 4. Okay, so that's probably the simplest way to solve this problem. However, it's important to understand that although this is the form we probably would have wanted to use, we could still use another form, and depending on how you arrange the information, it could be easier or harder. So I like to use graphing form. Okay, I always try to use graphing form whenever possible. So if I know anything about the middle, I try to use the middle. And just visually, my middle looks like it's at 1 or negative 1. In fact, I can find my middle p-value by taking the average of my zeros. Okay, so in this case, if I go negative 4 plus 2 divided by 2, I get p equals negative 1. And that's pretty clear from my picture, actually, that it's at negative 1. So I can actually then solve this equation, solve this problem a slightly different way. And so I'm going to call this version 2. Okay, so this is solution version 1. But since I have the middle now, I can do this. Y equals, I don't know a. I do know that my x middle is negative 1. So I'm going to use plus 1. And notice that's different than the factors. The graphing form and the factor form are different, right? This does not tell me the same thing as this one. Okay, and then we just don't know the q value. But we do have a couple coordinates and a y-intercept, so I can just plug in some points here. So I'm going to put in y equals 4 and come up with an equation when x is equal to 0. So I get 1 squared plus q. So that's a plus q equals 4. And I can come up with a second equation with one of the zeros. So y equals 0 when x is equal to, let's use x is equal to 2. 2 plus 1 squared plus q. Okay, simplifying this, I get 0 equals 9a plus q. So I have a system of equations, two variables, the system of equations. I can solve this. I can solve for I'll start with q. I'm going to eliminate the q value. So I'm going to start with equation 2 and subtract equation 1. Okay, so when I do that, I end up with 9a plus q minus 4 minus 1a minus q. Okay, so I end up with negative 4 is equal to 9 minus 1a, so that's 8a. And I get q minus q, which is 0. I solve for a. A still works out to be negative 1/2. And when I substitute in for the q, I get negative 1/2 times 9. So q is equal to negative 9a, so which is negative 1/2. Okay, so I get q is equal to positive 4.5. Okay, so there's my q value. And so I have an equivalent equation here. Y equals negative 1/2. That's the right a, because I got negative 1/2 up here. X plus 1 squared, okay, plus 4.5. Okay, so there's my equation. This is the graphing form of the same equation. And these two equations here, I'm just going to highlight them. This answer and this answer are in fact equivalent equations because they're the same parabola. Just one's in the factored form, the other one is in graphing form.